Hello there and welcome to the June 2018 applied paper. Here we're looking at question 8. A particle P moves along the x-axis. At time t seconds, t is greater than 0, the displacement x meters of P from the origin O is given by this expression here. Find the times at which P is instantaneously at rest. Now for something to be instantaneously at rest, dx by dt needs to equal 0. So let's differentiate it. Well, first we might want to expand the brackets. So it's going to be a half t to the power of 4 minus a half times 2 is just minus 1, and that would be t cubed. And then the next bit is going to be plus a half t squared. So let's now differentiate that, and it's going to be 2t cubed minus 3t squared, and then plus t just on its own, and then that will equal 0. So let's now factorize out the t at the that's a common factor in all of the terms, plus 1. And let's now factorize the quadratic, 2t t. So it's going to probably be minus 1 and minus 1. That will give us the minus 2 and minus another 1. That will be minus 3. Good. So therefore t will equal 0, t will equal a half, and t will equal 1. Those are the times that P is instantaneously at rest. Moving on to part B, find the total distance travelled by P in the time interval from 0 to 2. So this is quite a complicated question actually, because probably what's going to happen is we'll start with 0, then we'll go up to a half, then we'll stop, and potentially we might turn back round again, or potentially we might just carry on. So it's difficult to tell. So what we'll do then is we'll divide our time in between the interval from 0 to a half to 1, and then 1 to 2. So let's substitute in the value for t equals 0. If we substitute t equals 0, then we start at x equals 0. When we substitute in t equals a half, then x is going to equal, let's substitute t equals a half into all of that expression there, and we get 1 over 32. Then let's substitute t equals 1 into that expression, and we're going to get 0. And then when t equals 2, we're going to get, substitute 2 in, and we're going to get 2. So what's evidently happened here in the journey of this particle here, it's travelled from 0 out to 1 over 32, back to 0, and then back out again to 2. So it's going to be a double journey of the 1 over 32, and then the journey from 0 to 2. So it's going to be x, the total distance travelled is going to be 1 over 16 plus 2, which is, well, we could just write that as a mixed fraction, couldn't we? 2 and 1/16. And moving on to part C, show that P will never move along the negative x-axis. Well, if I just not complete the square exactly, but just factorize what's inside that bracket, it's going to be t minus 1 squared. So as a squared expression is never negative, is always greater than or equal to 0, greater than or equal to 0, x is always going to be greater than or equal to 0, because it would just be two squared numbers multiplied together, half it, yeah, that doesn't really affect anything, so it's always going to be greater than or equal to 0. So there we are, that's the answer for question 8, worth 10 marks in total there. Let's now move on to question 9.